Hello friends, I am Pankaj Jain, Assistant Professor in Physics from Engineering College Bikaner. In this video lecture, we are going to discuss an important topic which is named as Poynting theorem and Poynting vector. This is part of Engineering Physics unit number 6, electromagnetism, uh, by the prescribed by the Bikaner Technical University. Let us move on the topic. What is Poynting vector? Let us consider a unit area. Let us consider a unit area which is placed perpendicular to the direction of propagation of electromagnetic wave. Then amount of radiations which cross this unit area, amount of radiation energy which cross this unit area in unit time is called Poynting vector. Here I have defined Poynting vector. The energy transported by electromagnetic wave per unit area per unit time. The energy transported by electromagnetic wave per unit area per unit time is called Poynting vector. Mathematically, it is denoted by S, and it is equivalent to 1 upon mu naught multiplied by E cross B, where E is electric field vector and B is magnetic field vector. If we want to consider unit for Poynting vector, then unit for Poynting vector is watt per meter square, because it is energy crossing unit area in unit time. Therefore, unit will be watt per meter square. Let us move on the next slide. In this slide, we are taking sorry. In this slide, we are considering Poynting theorem. Poynting theorem is basically law of conservation of electromagnetic energy. Let us start to prove Poynting theorem. Let us start with Maxwell's third and fourth equation. Maxwell's third equation is del cross E is equivalent to minus del V upon del T, and the fourth equation is del cross H is equivalent to J plus del D upon del T. All we know the meaning of symbols here. J is current density, D is displacement vector, electric displacement vector, and H is magnetizing field, etc. Now what we are going to do, we are multiplying equation 1, or we are taking dot product of equation 1 with H and dot product of equation 2 with E, and then subtracting. What we get here, we have multiply H del cross E, H dot del cross E minus E dot del cross H in left hand side, and in right hand side what we get, it is right hand side we have H dot del V upon del T minus with minus sign, also minus J dot E and minus E dot del D upon del T. Okay, let us move on the next page. Now equation 3 using vector identity. There is a vector identity according to which del dot A cross B, where A and B are any two vectors, can be written as B curl of A minus A curl of B. If we use this vector identity in the left hand side of equation 3, which is on the page number 2, if we use this vector identity, then H dot del cross E minus E dot del cross S may written as del dot E cross H. Okay, using this vector identity. Also, two terms, one is H del B upon del T, can be converted as shown in this page. Here I have written H is equivalent to B upon mu, and del B upon del T is continuing, uh, and this term can be written as 1 upon 2 mu del upon del t b dot b. Okay, uh, if we differentiate b dot b with respect to time, then we get two similar terms. Each one will be equivalent to b del b upon del t, and we have divided by 2 so that we get b del b upon del t divided by mu naught. Okay, therefore this quantity can be written as this quantity, and again b dot b will be equivalent to b square. Therefore h del b upon del t is equivalent to 1 upon 2 mu del upon del t of b square. Similarly, another term E del d upon del t can be replaced by E del upon del t, and d is replaced by epsilon E. And then again, this term can be written as 1 upon 2 epsilon del upon del t of E dot E, because if we differentiate d dot d with respect to time, then we get two similar terms. Each one will be equivalent to E del E upon del t, and we have divided by factor 2 so that we get one term of this type. Okay, therefore finally E del d upon del t may return is equivalent to epsilon by 2 del upon del t of E square. Okay, let this equation is named as 6, this equation is named as 5, and this is equation number 4. Using these three equations in equation 3, what we get? What we get if we use these equations in equation number 3, then in left hand side we get del dot E cross H, where we have used vector identity which we have discussed in previous page, and the quantity negative of H del b upon del t is written as 1 upon 2 mu del upon del t of b square. We have no change in this quantity j dot e, and the quantity negative of E del d upon del t is replaced by minus epsilon by 2 del upon del t of E square. Okay, now taking volume integration of both side of above equation. We are going to take volume integration both side of above equation. What we get in left hand side, integration del dot E cross H dot dv. Okay, in right hand side, first and third term are connected, are joined with each other. Del upon del t is taken common, and we get b square upon 2 mu plus 1 by 2 epsilon E square in the bracket, and it is multiplied by dv and integrated. Also we have this term which is volume integration, j dot e volume integration of that quantity. Okay, now using Gauss divergence theorem, according to Gauss divergence theorem, if we remove del divergence here, then volume integration will convert into surface integration. We have removed divergence sign from here, and volume integration is been converted into surface integration. Therefore, volume integration of del dot E cross H is equivalent to surface integration of E cross H. Okay. Also, 1 by 2 epsilon E square plus b square upon 2 mu is equivalent to sum of energy density due to electric field plus magnetic field. Here, this is energy density due to electric field, um is energy density due to magnetic field, and these are replaced by uem, that is energy density in electromagnetic field. electromagnetic energy density. Okay, if we replace these quantities, then equation number, uh, I have not given any number this equation, above equation will convert into, let us move on next page. We have discussed the phase. Okay, move on next page. Therefore, in left hand side, we have surface integration of E cross H. We have surface integration of E cross H is equivalent to, we have taken del upon del T outside of integration sign. Therefore, it will convert into d upon dt. And half epsilon E square plus B square upon 2 mu naught will convert into energy density in electromagnetic field, that is written as UEM dot dV, and the term J dot E dV is as written as previously. Now this quantity is transferred into left hand side. This quantity is transferred into left hand side. Sorry, this quantity is remain in this side, but this quantity is replaced in left hand side. What we get, minus d upon dt of u em multiplied by dv and then integrated is replaced by, here this quantity is replaced by capital UEM, where capital U represent total electromagnetic energy inside a particular volume. Therefore, we have d upon dt negative sign with negative sign, d upon dt of UEM is equivalent to surface integration of E cross H plus this quantity is transferred into left hand side. Therefore, it will be plus sign. It will be equivalent to integration of J dot E, volume integration. This is the mathematical statement of Poynting theorem. This is mathematical statement of Poynting theorem. This is basically law of conservation of electromagnetic energy. Law of conservation of energy, or we can say that law of conservation of electromagnetic energy. Here in left hand side, the rate of decrease of total electromagnetic energy in a particular volume. If we see this left hand side, then it represent rate of decrease of electromagnetic energy in a particular volume. It is equal to sum of two terms. It is equal to sum of two terms. One is integration of E cross H, surface integration of E cross H, surface integration of E cross H. This represent electromagnetic energy flux coming out from the closed surface enclosing that particular volume. Okay, let us see on next page, move on next page. And the another term represent the rate at which work done on all charges in the volume. Let us consider a particular volume and let electromagnetic waves are coming out from this closed volume. Okay, then rate of decrease of electromagnetic energy in this particular volume will equivalent to sum of energy coming out from surface enclosing this volume and work done on all charges in this volume. Therefore, it is basically law of conservation of energy, or it can be written as law of conservation of electromagnetic energy. If we move on the previous page and see the quantity E cross H, what it represent? It represent energy, electromagnetic energy flux coming out per unit time, per unit area. Therefore, if we take a unit area, I again here I am taking a unit area, then the amount of energy coming out from this unit area will be equivalent to E cross H, and this quantity is known as Poynting vector. And hence Poynting vector which is denoted by S may written as S is equivalent to E cross H, and its unit will be watt per meter square. Okay, thank you students.
Hello friends, in this video lecture we are going to study Poynting vector and Poynting theorem, which is part of electromagnetism unit 6 of engineering physics. I am Pankaj Jain, assistant professor in physics, Engineering College Bikaner. Let us define what is Poynting vector. We can see here some electromagnetic radiation, electromagnetic wave are propagating in a particular direction, and a unit area is taken perpendicular